Right, so what I want to do with this segment is talk about the traction circle. And so what we're considering here is that we have a certain amount of force available to us for braking and accelerating. And we can draw that as a force vector in the two directions that we're going to act in terms of the motion of the car. And those are about equal and opposite. We can do one or we can do the other. We can also be turning, and there's a certain amount of force that we can put through the tires to get traction to allow the car to turn. And so that allows us to draw these four vectors. Now, there are conditions where we want to be able to do two of these things at once, braking and turning, for instance, or accelerating and turning. And in that circumstance, we can imagine a circle that ties all of this together through the equation of a circle, more or less. And we can then describe that, for instance, if we want to do a certain amount of braking and turning, that this might be how much we want to do to maximize what we can gain, and that circle defines our maximum outer limit. And so then we find, if we extrapolate that to the x-axis, that we got a certain amount of turning force. Extrapolate it to the y-axis, we get a certain amount of braking force. And that's the maximum we can get. If I try and get more braking force, let's say I try and apply this much braking force while I'm applying that much turning force, then I'm going to add up to a vector that extends outside the traction circle, and that says that I've started sliding. So that's an unsatisfactory situation, obviously. What instead we could do is try and change the shape of that circle. So let's consider that for a minute. When you apply the brakes, you're shifting weight to the front end of the car. So that's going to, in fact, increase the amount of traction the front end has for braking. So that expands the circle. It also puts more weight on the front wheels for turning, so it expands the circle for turning as well. So we can, in fact, increase our traction and our traction circle by applying the brakes and tipping the car in that direction. It's going to decline what we can do in the opposite direction. And simultaneously then, or not simultaneously, but at the same time, if you think about it, then when we apply the throttle and we put more weight transferred onto the back, then we're going to get an enhanced traction on the back. And equally so, when the car leans on a side, we can gain more traction on the side, on the outside of the car, to grip better. So we change the shape of the traction circle by transferring weight around the car by using our inputs to the throttle and the steering wheel and the brakes. So that's a powerful tool for changing what you want to do when you're driving the car. All right, well, what happens, let's take our same circle here and then ask the question, well, what happens when the conditions change? So I've got numbers for rain. We've got only 70% of the acceleration traction, only 50% of the braking traction, 20% of our turning power. And so obviously our traction circle is quite a bit smaller. You can see where this is going, right? Because if you now consider, well, what's going on when we're on ice, obviously that traction circle gets a lot smaller. So that's the world we're going to live in, and that's going to mean that we're outside the circle like we were over here, and way outside the range where we get traction. So we will start to slide the car. And if you think about that, we can define, repurpose this particular curve. We can think of this as being our rolling friction, and then we can think of this one as being our sliding friction. So it's reduced. Now the thing is that supposing we're trying to turn around a corner and the car is generally moving in the direction around the corner, but it's sliding outwards in this direction and not got the same arc as our corner does. Maybe I didn't draw that with quite enough exaggeration. But if now what I do is pitch the car sideways, so it's sitting like that, what I've done is I've increased the amount of friction that sliding is going to create, because now I've got all four of these wheels working against that direction of motion. They're creating friction against that direction of motion, which allows me to get the direction of motion that I'm looking for to a greater extent. So in other words, what I've done is managed to increase this component of the curve by pitching the car and making it slide. So even though we're sliding, we can use the ability to throw the car, to pitch it, to slide sideways, to still use sliding friction to our advantage, and even to enhance it by changing basically the shape of the car's interaction with the forces that are involved in making the corner. All right, so we'll stop there, and you